Welcome to the Learning Objective 1 exercise 4. We're going to talk about normal distribution and how to derive probabilities from it and how to plot it. You can download this file as always from our website, and it includes three tabs: exercise, exercise solution, and a question. In exercise, we're going to do the calculation. In exercise solution, the whole calculation is already provided for you, so you can check your formulas. As you can see, we will we will do together such a nice plotting of a normal distribution, and later on, in the question tab, you are going to be given a different data, and you're going to replicate uh, this exercise, but with different questions and different probabilities calculated. So let's get to it. Normal distribution is a distribution which is defined by only two parameters, mean and standard deviation, as you can see here. From these two parameters, we can derive everything about it, and we can calculate probabilities for any specific situation. And we'll start with plotting of the normal distribution. So, as you know, normal distribution, uh, vast majority of all instances happen in between -3 and 3 standard deviations from the mean. And the number of standard deviation is also called z-score, which I provided here. The formula how to calculate the z-score is basically how any given data point, how far is it in from the mean measured in standard deviations. And because we know that the majority of the points is always between -3 and 3, we know that we can just plot it for these numbers. But to be on a safer side, we're going to actually calculate for -4 and 4 standard deviations. So we'll start at -4 and we'll end at 4. In that will basically ensure that all of the data points are included. Uh, for these z-scores, we basically want to recalculate or reverse engineer the x, which in our case, because we're talking about still talk about the SP 500 stock in change. So the x is basically the daily change in a stock market, how much it yields or how much it loses in one day. And later on we'll calculate the probabilities for it. So first, we know we want to stay in between -4 and 4. So what is the yield which corresponds with 4 standard deviations? Well, it's going to be quite a huge drop in the stock market, wouldn't it? So all I have to do is basically calculate the x out of this formula, provided we know the mean and standard deviation. So I want to the x will be equal -4 times the standard deviation, which we have at the other side of of this sheet, and plus the mean. And this is the daily loss of the stock market, which corresponds with the 4 standard deviations from the mean. As I said, it's quite a huge loss in the stock market. And we'll do the same thing for the 4 standard deviations to the plus. So all I want to do is copy this formula down, but at first I want to log the mean and standard deviation in the formula and copy it down. And because the mean is very close to 0, you can see that the loss is almost as big as gain in the other direction. Because we want to plot the normal distribution, I want to basically calculate as many x's in between these two numbers. These are basically just the border numbers. So I'm going to calculate the range out of these two, which is, as we did in one of the previous exercises, uh, the upper value minus the lower value, and then how many points I actually want to plot in between. Quite a lot. It can be almost any number, but let's say at least 5. Let's say it's 150. So I'll divide the range by 150, and this gives me one category width, which is a very tiny number, isn't it? So uh, now I don't want to lose this data when I change the calculations over here. So I'm going to press Control C, and when instead of paste, I'll just press this button over here, which basically just the data still stays there, but instead of the formula, you can see it's just a hard set number, nothing else. And I'm going to delete this part. So this is our lowest point in our distribution. I'm going to always add just a category width to it, and I move from this number by this much to yet and to next data point, and I'll do it about 150 times down. Because I just want to copy it, I'm going to lock the category width, and now I'm just going, it's too much, down. It nicely calculates over here how far I went along, and I want to, because I already have two points up there prepared from before, I'll have to go just 149 and press it down, and I started at minus 3.89 and I finish at plus 3.89, which is exactly as I wanted, equivalent to minus 4 standard deviations and plus 4 standard deviations from the mean. Okay, so this is basically kind of randomly plotted, daily gains, in this case, like in this part of the distribution losses and gains on the stock market. Now I want to calculate the probabilities of that actually happening. And to do so, I will use a shortcut. I will use the Excel very handy norm dist formula which will calculate the probability with me. For such a big loss over here, minus 3.89, the probability is going to be probably really low, because the stock market, most of the values should be somewhere around zero. So the stock market to lose 4% almost every day, or like next day, it's not really probable, is it? So I can expect that the probability will be very low. So norm dist, and now it just asks me for a number of data coming in. So first I want to know the x values, which is the one on the right, mean, as we have it over here, standard deviation, which we have over here, and now it asks if I want a cumulative or probability mass function. Well, we don't want cumulative, because it would basically calculate the everything up to this point, and we just want to know how probable is this particular instance. So we will choose false. Close the brackets, and as I said, the probability is very, very low. Again, as with other calculations before that, because I want to copy it down, I want to log certain parameters in it, and like quite handily shows me here what I'm right now working on. So this one, I probably want to lock it, right? Because standard deviation doesn't change. So I'll just highlight it and press F4, and it locks it with dollar signs. The same thing I do with the mean. I want to lock it so it doesn't change when I copy it down. And now I highlight the whole formula, click to the left, Control Shift down arrow, move to the right, Control Shift up arrow, one cell down, and Control V to copy it through nicely populated or probability distribution. So far, it doesn't really look like a normal distribution, does it? Because it's just a bunch of data, but you can see that in the middle, like around zero, of course, the numbers are much higher because probability of that happening is much bigger. So if you want to plot it to get a better picture of what we are looking at, we basically just first we have to highlight the data we want to plot, then go insert, choose the column chart. I probably should have moved up first so the chart is in a position where I want it. And here we are, a nice normal distribution. So I'm going to make it bigger. Uh, I can see that there's a little bit of a flaw. This thing doesn't really represent X as I wanted, so I don't know actually what the probability is for. So I'm going to change it by right click on the axis, select data, edit, choose range, and I'm going to choose this range over here. It's a lot of data. The Excel is struggling a little bit. Okay, we'll return up. And now we have the the daily gains and losses all on the axis and the probabilities of happening. So maybe we should also change the design of the chart a little bit, choose a nicer one. Maybe this one will be quite nice, or any other one which you might like. Also, even though like there's 150 columns over here, we are still dealing with a continuous variable, so it will help if I change it to no gaps between columns, so it looks like continuous variable. But I do so by, I'll show you once again. You double click and this format data point opens, and I'm going to change the gap width, and it just makes the distribution look much smoother because it gets rid of the gaps between the columns. All right, so the normal distribution is plotted, and we'll get to the questions. The first question is, calculate the probability that the index will gain more than 2% the next day. All right, so if I look at the distribution over here, 2% is somewhere over here. And for the index to gain more than 2%, it basically is just this little area over here, which, you could probably get the same answer from Z tables and from like empirical rules about normal distributions. But you can also do the same thing using by Excel formulas, and you do it, the results you're going to receive is much more accurate. So let's get to it. So we'll use the same formula as before, norm dist. Here we go. It wants the x, which is again like we know it's 2% because that's the that's the question, if it's going to lose or like if it's going to gain more than 2%. So 2 standard deviation. Oh, sorry, mean is first. So mean, standard deviation, and this time we want cumulative, because we just don't ask how likely it is that it's going to be 2%. We want 2% and more, so we want basically calculate everything from 2% on. So I'm going to click on true on cumulative. uh, by the way, I already know that like this is actually not going to be enough because it's going to calculate like the cumulative probability from the left to the right. So I'll have to do a little adjustment to the formula, but I'll show you why. Now I'll finish it as it is, and it gives me 98%. And if I look at the distribution once more, so what I did right now, I actually calculated this whole area up to 2%. That's why it's almost 98%. Of course, as with any probability distribution, the whole area under is 100%. So I basically calculated from minus infinity all the way to 2%. Well, that's not what I want. What I want is exactly opposite. It should be just this little bit over here. And to do so, I basically just reversed the formula 1 minus the formula I had there before. And it's 1.998%. And I did the calculation before, so if you look over here, I already had the result over here, so I know it's correct now. It's just under 2% probability that the stock will gain more than 2% the next day. The next question. Calculate the probability that the index change will be positive the next day, which means it will have to be over zero. Again, if we look at the distribution, well, the mean is very close to zero. So, and normal distribution is always symmetrical. So the probability that it will be over zero is very close to 50%. I already know that. But because the mean is actually not exactly zero, it's actually positive. That means that it will be just over 50%. But how much is it? Well, we could get like, we could basically say, oh, it's almost exactly 50%. So we'll just leave it be. But with investing, there's a lot of money involved. So we probably want as an exact number as we can. So we'll basically do the same thing as before. What's happening here? I can just change the formatting over here. So not so many decimal points actually show up. Maybe 4 is just enough. Okay, so the same formula as before. Norm dist. And x is this time 0. Mean is our mean. Normal standard deviation, and again we want cumulative, and it's basically the same thing as before. We want to know the other side of the distribution, so it's again 1 minus norm dist, and indeed it's 50.06%. And I actually did the calculation before again, so you could see that I arrived at the same conclusion. Question number 3. Calculate the probability that the index will stay between -1 and 1%. Well, that's a tricky question, isn't it? You basically want to know the probability between 1%, which is somewhere over here, and 1%, which is somewhere over here. So only this middle section of the distribution. Well, how will we do that? We basically want to exclude this part and this part. Well, we'll probably have to combine two norm distributions to do it. So first, we're going to, as I said before, the norm distribution calculates the probability from the left to the right. So what you want to do is calculate the probability for this section up to 1%, somewhere over here, so this section, and then you'll calculate the probability for this section over here, and subtract it from the calculation from the probability you received previously. So norm dist function x. So we calculate all the whole probability till the 1%. Mean standard deviation cumulative, close the brackets, minus another norm dist function, and our x this time is -1, and now it wants the mean again, standard deviation, and cumulative again, and our result is 69.59%, which again, we've seen here before. The calculation happened over here. So that completes our exercise. As you can see in exercise solution, we have also arrived at the very same numbers. I have a little bit different formatting over here. I can change the formatting on this cell to show you that it's actually the very same number as I had over here. So complete your calculation. We have a different set of the questions. Some of them are a little bit tricky, so good luck. And when you finish, just upload it on our website and you'll receive our feedback. So thank you very much for your attention once again, and see you in the next exercise.